Okay, welcome to another in-depth series with Open Team, and we're going to explore Comet Farm today with the Comet team at CSU. If you have questions, you can put them into chat, and we'll catch them as we get to questions. And I will hand it. Oh, and mute if. During the presentation or until you have a question. And with that, I'll hand it off to the Comet team.
Okay, thanks, Doran. So I'll just start off here. So I'm Keith Fostian. I'm the PI of our group here, but I'm here also with Mark Easter, Kevin Brown, and Mark Blair. So there's the four of us here in the room. And yeah, so we're going to talk about the work we've been doing. A lot of this has really been in a strong collaboration. I want to mention USDA and NRCS over a number of years. And so this is, and some of the folks here in the picture that you see are you know, part of our team. And then we were fortunate, we had about 3 years ago, Secretary Vilsack was here on a visit, and so he got to meet folks and got a nice photo op. So anyway, but let me launch into what we're going to try to present here fairly succinctly is kind of an introduction to the, you know, to the system and the tools in terms of the, you know, the objectives and a little bit of the history and stuff. And then Kevin, who's our chief software architect here, is going to go into the architecture of both the Comet Farm system and a kind of a derivative tool called Comet Planner, which I'll explain here in a minute. So Kevin's going to go into some of the nitty-gritty on that. And then Mark Blair, who's one of our software developers here and kind of in charge of the API, is going to talk briefly about that, and then we'll have a question and answer period that we just throw the floor open. Okay, so Doran, and go ahead and jump in if you if we're missing out on something or you want us to do something before we launch into this. Just go ahead and let us know.
Absolutely, but this looks like a great agenda. So
okay, all right. So so first, a little bit of a background on the Comet tools. And so this kind of depicts the idea, you know, we really want to provide a tool that will allow farmers or really anyone else who is interested in looking at implementation of conservation practices to be able to do kind of what if scenarios at the farm scale, to both kind of do ex ante projections and say, well, what are potential, you know, likely outcomes in terms of carbon and greenhouse gases for changing management, adopting conservation practices, but also the tool is applicable as really kind of a greenhouse gas inventory system as well, to kind of track what's already happened and what are the consequences of changes in management over time. So in terms of key attributes, so the first thing to note is that really it's designed to be a full greenhouse gas and carbon accounting system, but within the farm gate. So we look at sort of all the emissions, all the carbon stock changes that occur on farm. We don't directly in the tool report on sort of upstream or downstream kind of emissions, but you know, the tool has been used in that kind of a context to do more of a life cycle assessment, but it's really not set up as a life cycle tool per se. It implements this USDA entity scale guidelines. You see as an image of we call it the Blue Book, which came out in July of 2014, and that was the end result of about a 3-year effort that the USDA's Climate Change Program Office in Washington, D.C. set up to convene a number of expert groups that worked for about 2 years and developed and came up with recommendations on methods for all the source categories that have to do with land use, so forestry, you know, grazing lands, cropland, etc. And so basically the methods that are in that blue book are what are implemented within Comet Farm. The system has a full spatial interface with high resolution climate, soils, and land cover and other kinds of spatial data layers. It also includes a number of models, both empirical models as well as process-based models that run essentially on the fly. And it's on the web. It's free. Sign up if you want to save your data from session to session. But otherwise, it's open to anyone. Just really quickly, I guess this kind of shows a little bit of a kind of a structural diagram, if you will. And the point I guess I want to make here is that really Comet Farm is really this platform. So it's not a model, but it's the data, the user interface, a number of models. And you can see kind of at the beginning, the idea is there's a web interface, and because it is a entity scale, the idea is that the land manager or their representative that knows exactly what is happening on the landscape is putting in information about both their past as well as their current, as well as their future management with respect to cropland grazing lands, livestock, energy use, agroforestry, etc. And that data then is stored and along with other kinds of management data that's in the back end, and sort of creates the data layers that that drive the different models that are shown down here in this calculation module, if you will, and then that is tied to a reporting module. So that's kind of the nuts and bolts, I guess, of the model structure. If you go in to use the tool, this is kind of a simplified vision of what the workflow looks like, where you kind of go in and you identify what your source category is. Do you only want to look at cropland? Do you want to look at cropland and livestock? And once you do that, you kind of enter your management data, and you can see here on the left-hand side, you can identify specific fields, either by outlining what the fields are. You can also drop a pin into an area and tell the acres that you want surrounding that pin to represent your land units. You enter similarly information and demographies about your livestock herds, etc. We've tried to add a number of things. So there's quite a bit of data entry, obviously, if you're doing field by field or livestock herd by livestock herd. But we also have tried to implement some shortcuts. And one example here, you can kind of see in the middle, got this thing we call the drag and drop facility, which allows you to go in and sort of identify, kind of quickly build a crop rotation using these icons and specify kind of a bare minimum amount of information about the management. And then it allows the system to use kind of regionally specific defaults to put in, for example, your nutrient management practices, what would be typical for those crops in that region. So it allows a user that wants to go in and just kind of set up a scenario to kind of quickly populate the inputs to the model and then get an output. But you can also go back in later and kind of detailed, do a detailed entry on all your different management options. And you can't probably see very well here, but there's a set of kind of flow lines or something here, and I'm not sure you can't really see it here, but it shows you can go through and specify your planting dates and your tillage practices, your nitrogen management and residue management, manure applications, and different things like that. The system provides a sort of an online reporting set of tables that you can look at different, your baseline scenario versus a number of different project scenarios. You can also download the data into a spreadsheet. It's got a number of kind of simple graphs and figures that you can also generate from it. So it's that's kind of what it looks like. Now I want to just kind of pivot over to something that we call Comet Planner, and Comet Planner is kind of think of it as a little bit of a spin-off tool from Comet Farm, and it was really designed initially to kind of provide a first order estimate of greenhouse gas reductions if you adopt conservation management practices. So as opposed to Comet Farm, where an experienced user might take them I don't know, they might spend half an hour if they've got a number of fields and livestock herds and stuff like this, entering all the data, whereas Comet Planner was kind of developed as I guess what I would call almost a 3-click tool. In other words, you just want to go in, put in a minimum amount of information and get a kind of a regionally relevant estimate of the impact of these greenhouse gas management practices. It is closely aligned with NRCS's conservation practice standards, so that basically you choose from the menu of those conservation practices, but it's the estimates that are provided in the tool are derived from the kind of the base Comet Farm technology that I described earlier, and so I'll just kind of show quickly how that works. So the methods and the results then also align with the methods in this blue book that we mentioned before. And so the difference is that the conservation practice standards are prescribed by NRCS, documents and things of this nature. So we've worked with NRCS and with stakeholders within a particular region to define exactly what's that conservation practice standards mean in terms of a prescription that's relevant for a certain type of system in southern Minnesota versus northern Georgia or something like this. But because it is this simple kind of a lookup tool, if you will, the baseline is assumed essentially. So the user doesn't specify what the current baseline situation is. It's basically making the assumption that you're practicing the conventional, most common practice for the particular area. In terms of how how the numbers are come up with, this kind of illustrates that basically what we do is, and here is showing for California, is we basically take the land area that we're concerned with, in this case would be cropland located within California, do a random sampling of points on the landscape that then intersect with things like the cropland data layer, so that we can get a time series of what the estimated crops over time, so essentially a remotely sensed crop rotation estimate, if you will, and then combine that with what the points are landing on an area that defines what soils are there, using the Surgo soils information as well as climate. We use the Prism climate data for weather data for precip and temperature. And then we again, for the particular regions, we supplement that with information on what the typical management systems are for those crops based on things like ERS arm surveys and et cetera. So we essentially build up what both the baseline and the conservation practice standard management is, and then those model inputs essentially get run through the Comet API, and I don't know, Mark could probably, certainly the most recent set of estimates that we ran for the 48 states in the U.S. I don't know, ended up with several 100,000 points, I think, and then I don't know, something on the order of about 30 different 30 plus different conservation practice standards. So it's a pretty big combinatorial set of results, but that basically is what generates then the data that sits underneath Comet Planner. But as a user, you come in, you don't obviously see that complexity. You kind of go in, you can actually, it's set up now using English and also Spanish. You go in and say, okay, here's my, I'm in this state, here's my county, and then I pick a land use type, cropland versus grazing land, woody plantings, looking at restoration of disturbed lands. Those are kind of the major categories that you can choose from. Once you choose, say, Cropland Management, then you get a menu over here that shows you which conservation practice standards that you could choose. You choose one of those, you do an implementation of what that standard is, and then you put in your acreage, and it generates the report for that particular standard on that area that you've specified. So it's a pretty simple tool, and it's been, it was originally designed to be used as part of the California Healthy Soils Initiative, and that's kind of where the impetus came from. And then just finally, current applications are, these are certainly not all of the folks and applications that people are currently used, but I think it represents kind of what our current user base is, and it's changing, fairly rapidly. We are working with some of these state programs, initially with California and Colorado, Maryland, and now that's expanding to a broader set of states within the U.S. Climate Alliance. We've also, worked with several companies that want to use the system for the kind of sustainability metrics, and we've talked about this in previous meetings. USDA, of course, they're our primary sponsor, if you will, and so they're using it for some of their programmatic stuff. Don't know if the NORI folks are on the phone, but we've been working with them over the past several months because they're using the Comet system as part of their carbon removal marketplace strategy. We've also worked with a number of NGOs and some of the folks in California, Marine Carbon Project, et cetera. Some of the methods that are implemented here also have been set up for offset protocols by Climate Action Reserve, American Carbon Registry. And then we have some interesting applications too. We get students, sometimes business students from University of Michigan, who cold call and say, hey, we want a project, we're doing a thing, and we want to use the Comet farm system. So we have some fun with those guys as well. That's I think all I was going to say in terms of introductory remarks. And I don't know if we want to take maybe a couple of questions, Dorn. Then we're going to sort of dive in a little bit more of the technical details that Kevin is going to give on the system architecture.
Oh, yeah, pause for a moment if anybody has some questions, general questions before we dive in. If not, we'll dive right into the guts of it.
All right. Okay, Kevin.
All right, Dorn, it's been a while.
Yeah, hey, Kevin, it's great to have you on the phone.
Yeah, absolutely.
Video call, I guess.
So I'll get right into it, the Comet Farm system architecture. These slides are really just a brief overview of the system as it was originally designed and currently implemented. But certainly each one of these items can be dived into in great detail, and it can be further exhausted, each one of these bullets. So this slide here is really just a depiction of the current system. It really is quite simple. We have the user interface that was built on these major, fairly common components, .NET, C#, Bing Maps, openlayers, USDA. We'll go through these in detail in subsequent slides. Then we have the backend, which is again C#.NET, and that backend really is the key to providing the reports page. Keith had a few slides there that showed the reports page just briefly, but this is pretty straightforward. So we've got a user interface, we've got a back end, we have Datasets service. That can actually be replaced with services because it could be one-to-many services. Our main service is a Datasets service. And then we have a standard PostGIS database with other databases kind of represented by the CSU data drive database that we have. And behind the Datasets service, we have, I got this. I wanted to really call out the USDA greenhouse gas methods as the main source for how we drive the empirical calculations. So that in combination with Datasets is how we get our results in our reports page. Again, Keith went through this. There was a subsequent slide that showed the workflow with some screenshots. Here's how the workflow is just on a per page basis. We've got the landing page, which has a few different links, static pages with information. We also have a Comet energy tool. I don't have a screenshot of that, but it's really just a quick table where it kind of looks like Comet Planner. You can enter in your fuel usage and get out a simple table and a report on the greenhouse gas emissions associated with that fuel usage. But you don't have to be logged in or interface with Comet. So you get to that tool, you can more or less get to that directly from the home page. And then we have two different mechanisms to actually use the tool. We didn't want to require every user to have to register in Comet in order to use the tool. So we actually have a standard login, but we also have a continue without registration option. And the caveat there with the continue without registration option is that once your cache is cleared on your computer, that data associated with that session will no longer be stored. And so for users who continue to use the site, want to save their data, we always encourage them to actually register and log into the site. Once you're logged in, we have the activities that you select, the projects that you create. We have a number of demo projects as well to walk any user through, any first-time users or users who want to walk through a demo. You can select that from the activities page. And then there's all the activities that you can run scenarios on. So any combination of croplands, animal agriculture, agroforestry, and forestry, those all, once you go through the workflow, will take you to a reports page that can either be a combined reports page with each module broken out, or just whatever modules you selected, you'll see a corresponding report with charts and graphics as well. And we've got a link from the reports to the services back and forth there. That's where we get the numbers. So really that workflow and the subsequent page here are really the visual backbone of the system architecture. But let's dive into the graphical user interface overview. So this application was designed as a web application, pretty standard .NET application. So we see .NET 4.0 and we continue to upgrade the 4.0 as new versions of the .NET framework come out. We're using C#, JavaScript, and HTML for the front end, with the views having some of these common JavaScript libraries. So EXT.js, jQuery, ASP.NET, Razor, so HTML pages. That's all fairly straightforward. And we also have, I wanted to break this out into kind of a separate item, although it is a view in our app, which is the maps page. The maps page is highly functional. Again, we can really dive into it and look at all the different bits and pieces of functionality, but the core components are that we are now using a Bing Maps, formerly a Google Map. We had to switch that over to be compatible with openlayers, which we're now up to version 4.0, 4.0. I think maybe actually 3.0 still. And we'll end up upgrading that here in the next cycle. And then we use, a lot of different spatial layers, but the main one is the USDA Web Soil Survey. And, just a quick note on the maps page. There are other bits of functionality that aren't outlined in this system architecture overview, but pretty important components, so the user can go in and upload shape files to quickly outline multiple areas, which is essential for users that have lots of locations and don't want to go and outline too many individual fields by hand, as well as other functions to look up soil types, to view different attributes on the map. So maybe get into that a little bit later. Then we have a few slides that really break down those individual components, but we don't need to spend too much time going through these individually. I will spend some time here with EXTJS and jQuery. So EXTJS is less common than jQuery, and nowadays less common than Angular or React, but originally EXTJS was the primary JavaScript library used for all the widgets in Comet Farm, and over the years we've actually introduced more jQuery libraries to replace the existing EXTJS widgets. And EXTJS remains to be a maintained library, perfectly suitable to be used in Comet, but the desire to move toward more modern frameworks or more commonly used JavaScript libraries like jQuery, we've begun to do that. So you'll see that throughout the pages. And then just a quick note about the ASP.NET stuff and CSHTML. So there goes maps. Let's talk a little bit about the back end here. So C#.NET, you'll hear that a lot, you'll see that a lot. That's our primary language and framework of choice. Major design patterns used are all really familiar, so model view controller is the key there. That's pretty consistent throughout Comet Farm and Comet Planner here when we discuss it. That architecture as well. For our database connections and sources, our relational mapper we decided to use in Hibernate. We've upgraded that a few times, still currently at version 3.star. And we also have a Postgres database that houses all of our data and anything that we need to persist. In addition to that, we have a CSU research drive that we pull data from for primarily the Datasets service. We have a few different items there that I think we'll outline in subsequent slides, but are pertinent really to run Datasets on the fly. We have a number of services that Comet Farm needs to use. So the web soil survey we touched on, that's available on the maps page, but we also hit that on the back end as well, because we actually need to query the web soil survey to retrieve specific attributes of the soil for every location and every map unit. Datasets service, that's not an official service, that's actually our service created at Colorado State University for the purpose of running Comet Farm. It's a wrapper for Datasets, and we'll cover a little more on that subsequently. Yeah. And server hardware, originally created to be a single farm use tool for USDA and RCS. We are hosting this website at Colorado State University using our virtual server, SQL Server 2012, using IIS to support that. I also have a quick note here about the automated testing framework. That's actually outside of the core Comet Farm application. But the automated testing framework is really an entirely different app, but it's used to continually test Comet. So I just wanted to throw that in there somewhere. We can talk more about that in subsequent slides. Okay, quick distinctions here. We're seeing C#, Java. C# really is the .NET application language of choice. That's self-explanatory. The Java is actually used for the Datasets service that I was describing. So Datasets service is it's a desktop application. It's a service that listens for requests. We chose Java because Fortran or Datasets is actually was built. Fortran and C. Yeah. It was built in Fortran 88 or something like that, right? It's 87. It's been upgraded. But it's a combination of Fortran and C. And that's just the version that we use. Now, there are other versions of Datasets that can run in a Windows environment. This version is the one that we run and the one that we maintain and continue to update. And so Java, it was a better suited language. We actually originally started with Python, and then we upgraded to a Java framework and language, maybe like 5 years ago or something like that. So that's best suited for a Linux environment. Where you discuss the MVC design pattern. And Postgres is great. It's free. It's PostGIS, spatial functions. All these decisions are decisions that we made up front and are still, I think, great frameworks and databases for the purpose of Comet. So little detail about in Hibernate. I think our goal now is to move toward a fully parallel framework. So eventually we will be swapping out in Hibernate for the Entity framework. Okay, Datasets service, I think we covered that. Virtual servers, let me know if you have any questions about that. I think this is fairly straightforward. Windows Server 2012, we host it. It's a virtual server. It is backed up daily. It's running IIS. A little bit about the automated testing desktop application. So it's a Selenium app. It runs every day. It uses static tests to verify each publish. And in a perfect world, it runs every night and actually reports the testing results to us every single day. And for the most part, it achieves that goal. There are times that the tests need to be restarted or rerun, but this is one of the methods that we use to automatically test the app anytime we make any change, make sure everything's working correctly. So that's always being expanded and worked on to incorporate new tests and new verifications as needed. All right, before we go on to Comet Planner, which is it's a single page application, so that one's going to be really straightforward. Any questions on the Comet Farm architecture? We can really get into the weeds on this one, so feel free, anyone.
We'll just give folks a chance to unmute if they want to chime in here, Kevin.
Yep.
I've got some that I'll save till the end because it as well. If you want to keep rolling, anybody? All right, keep rolling.
Comet Planner. Keith touched on this. I think he explained it in large. It's a single-page application that really does share the same core technologies as Comet Farm. So .NET 4, C#, JavaScript, HTML, even down to the JavaScript libraries. EXTJS is still being used. jQuery, ASP.NET pages, with the backend being pretty much the same. Model view controller design pattern. And for the database on this, we actually are going to add a Postgres database originally designed to be a really simple single-page application. Now we will make a minor upgrade to the database just to make it more efficient and faster as we see an increased user base here. So we'll be replacing that CSU data drive that we currently use to pull the data when a user runs the application to be a Postgres database. That's really it. I mean, so the system user interface, it is a multi-language tool. We don't have that in here, but there are multiple languages. Just right now it's English and Spanish. You can click on a drop down and go from English to Spanish, and we'll likely expand that and continue to add more languages as needed, really. I think that's really it for Comet Planner. Backend is exactly the same. We're still hosting it at CSU. It's on a different server, same virtual environment. SQL, really Microsoft SQL Server 2012, IIS. Yeah.
Okay, Mark.
Gonna hand it over to Mark here.
Introduce yourself really briefly, maybe.
Hello, my name is Mark Layer, and I'm a software engineer here. And I did a lot of the late work on the Comet Farm API. So originally, we built this API to run internal runs to build up the database for the Comet Planner. And we've since been expanding it to be more publicly accessible and usable. It's designed to replicate the functionality of the Comet Farm Croplands module, which is you set up your farm, you give it management, and you run it through the Datasets service to get a simulation of the day-by-day emissions on that farm through that crop regime. We currently have a page here on Comet Farm that you can go to upload API runs. But since everything is done through post requests, this is just kind of like a sample, or if you have one or two. But we can hook it up, or using post requests, you can hook it up to other services and scripts and programs to more automate the process. On this slide, we have the page on the upper left is the page that the user would use to upload the API inputs themselves, and on the right is a status page, so you can see that the API is actually working, or what it's currently doing on, and how long the queue is, plus some time estimates. The inputs are in XML form, and they're designed to be as human readable as XML can be. And this is to try to keep things simple and explainable. But using XML, we can make it so that the API can process hundreds of fields in a single XML file with hundreds of associated scenarios, making it thousands of different Datasets runs. But we designed the API for bulk processing, so we can pack hundreds of runs into a single file, but we can also accept inputs that are hundreds of files zipped together. And that's how we did the bulk of the planner runs. So this is to help other users do maybe bulk processing like a whole state for their service. We tried to make the API inputs line up one-to-one as much as possible with the current Comet Farm GUI. So on the left, we have what the Comet Farm GUI is doing. And on the right, it corresponds to a line in the API input XML. So like upland non-irrigated for pre-1980s management, there's literally a line in the API inputs for pre-1980 is upland non-irrigated. In this way, we've also built the API to accept, because Comet Farm, the website, the GUI, we can export projects into XML form, and we can use those. You can use those as API inputs. In this way, you can build up a test case where you build your parcel in the GUI with management in a certain way and export it, and then you can use that as a template for more elaborate scenarios in other locations. So we're trying to make this as self-documenting as possible. When the API runs through and produces results, it will give you a little bit more results than the GUI will do for most users, because it'll give you also a lot of raw information that the Datasets service outputs, and the Dataset itself will output. So on the right, we have, this is all in the same file. On the right, we have earlier tags, which is Cropland's file outputs straight from Datasets, which is a year-by-year what these different things are doing. And the documentation on what these things actually mean should be found with documentation on Datasets. And on the left in the lower corner of this slide is the summary results, which should be the same results that you would get on the Comet Farm GUI. Here is an overview of how the system is laid out on the back end. Currently, the Comet Farm server does a lot of the processing of the input, using the exact same functions that the GUI does to get the same things from the database, like what are the attributes of corn and what are these tillages doing. And it bundles it up and sends it to our CSU rocks cluster for bulk processing, which splits it out into individual Datasets service runs and runs it on the compute nodes of our cluster to try to get this done as quickly and as many parallel processes as possible before bundling back up, sending it to Comet Farm, and emailing it back to the user's account. We do have code in place and have run this a few times to scale this up, not infinitely, but a lot more on the Google Cloud. And we had to do this earlier this year and it allowed us to run, I think, 360,000 Comet Planner runs in a matter of a couple of hours rather than over weeks. So if people come in with a lot of processing to do and they need it done pretty quickly, we are able to scale it up. That was a brief, quick run through of the API. Anyone have any questions?
Yeah, I think we do. Mike Stent is here up here, and he's got a question for you on input libraries.
Yeah, I was just wondering because Greg at RSI and Manuel and I, we were talking about standardized libraries of inputs, and I noticed that you had some in that XML there. I was wondering if you've kind of developed a library yourself of a list of inputs, or if you're pulling from somewhere else.
We develop these inputs based on how Comet Farm inputs are, what we do on the Comet Farm UI side. And that changes as the UI changes, as we add new crops and new classes of crops.
And Mike, this is Mark Easter. We can make that, that available for you. We've got a package that describes how to interact with the API, and it has a full list of what all the possible inputs are, the input structures, and what to expect in the output files.
Oh,
So
great. Yeah.
I'll add another thing that maybe, I don't know if this relates to your question, but so a few years ago, we were asked by, I think it was Delta Institute, I'm not sure, but they were doing some work with DNDC, and they wanted to use the Comet GUI to enter the information for the, for fields that they then wanted to run through the DNDC model. And we built an off-ramp, basically a facility which you could enter your data into Comet Farm, and then it exported files that you could then use into DNDC. The other thing is that we now also have a version we've been working with USDA's Climate Program Office to also have a version that includes water quality outputs from the Apex model. So we've been working with with folks on sort of implementing the Apex model also within this framework. So I guess the point of that was that we've been looking at what are the what's a common set of inputs that are needed to drive 3 different process-based models in this space, and so that's I see that as probably an area that our this group, the open team folks, are probably going to want to continue along to sort of identify what the full set of management specifications that are going to be needed to to run all our different tools.
Great. Yeah, that makes sense. Yeah, and I think from the FarmOS perspective, it would be really exciting to be able to send an API request from FarmOS that has information about the fertilizers that were used, but we would just want to make sure that we're matching those up properly. So, and I think that's a common problem with a common interoperability hurdle that we're all sort of facing.
That's going to be a big part of the work that we're going to be doing in this collaboration, is really fleshing out how to best serve what's needed by FarmOS, and also making sure that we've matched up the capacity within the services, both in the software and the hardware on our end.
Great.
I just see a quick comment from Daniela asking where to find API documentation.
I could send that out to basically to our user group. We've got that long email list. Unless there's another, is there a listserv?
That's part of what we'll be setting up at the Denver meeting as well. But perhaps if it's not urgent, Daniela, we'll address that as we launch into our Open Team project management sort of site.
Excellent.
Great. All right, we'll hand it back to you, Mark. Oh, we're into questions.
Yeah, we're done from our standpoint, I think, unless folks have questions that they want to ask.
Yeah, I wanted to, and I'm sure other folks have other questions as well, but two that I had was around your considerations for your weather data hosting as a separate service, and thoughts on that, and also if you've been able to see some of the other in-depth sessions on weather services in terms of hosting. That I would love just to get your general perspective on weather data sets.
It's an interesting question, and I did see that in the last, it's come up in a couple presentations, but there was some discussion about that, and I remember the cover crop tools. We're currently using the Prism weather data set or weather model, and we basically download the data as soon as it's updated and been verified by the Prism group at Oregon State. We update our data set, and then we we essentially pre-build a set of data sets, essentially files that can be used to drive the DayCent model on our end. And then the data, some of that data are also used in other aspects. Some of the animal agricultural models related to manure, nitrous oxide, manure, methane, and some of the other models use aspects of those data.
If you're not familiar with Prism, it's if everybody's not familiar, it's a gridded product of daily weather variables that is at I think it's a 2-kilometer grid across the entire 48.
It's 6 kilometers.
Is it 6 kilometers? I thought it was 2. Okay. All right. Well, anyway, but it uses it does interpolation between weather station data, so it accounts for orographic effects and things like this. And in general, previously we've used some other products, the NAR database and things like this, but Prism seems to be the most accurate, and and it is kind of I guess supported or sponsored by NRCS as well, so that is another factor, I guess, in our using that data.
I'm happy to engage in a dialogue with this group around potential other weather models that could be used, and and discuss what services are being created within Open Team.
Yeah, I think there's going to be some really interesting conversations, because I think there's several different hosted weather services that we don't seem to be consistent with. So that'll be good. Another question, we've got Greg here who's asking about sort of on the ground or ground verification or ground truthing Comet estimates, and what a process might be for implementing ground truthing.
Yeah, we do a great deal of that work with the individual models that are part of the Comet Farm platform. And so there's over 40 different models that are described in the Blue Book that we use that are implemented within the system, depending on what the land use category is and what the greenhouse gas source category is that's involved. And so the ground truthing that we do on the DayCent side is principally tied to, it's done in concert with the National Greenhouse Gas Inventory, and that's primarily done using data that have been published in peer-reviewed studies. We've got essentially a library of information from more than 100 sites worldwide, and over 1,000 experiments associated with those sites where there's been measurements of soil carbon and soil nitrous oxide and other aspects of ecosystem gas exchange, where that verification work happens with DayCent. And then other models, there are other data sets that we utilize for essentially for model verification work. It's especially with livestock emissions, and particularly with manure nitrous oxide and with enteric methane, those are particularly difficult to measure. And there are a relatively limited number of data sets that are out there. And so we rely pretty heavily on partners that have been funded by the Climate Change Program Office to do the essentially the model verification work there. I hope that answers that question.
That's great. We also had a comment from Greg back to the weather question. It looks, we were, I think, along the same point I was making, that Chris Freeberg-Horton, as you mentioned on the cover crop call, was using USDA Crown project, which is also using some of the same Prism data. Does that sound right? I'm going to.
Yeah, that's right. Yep. And they have like an API service they've provided and built a nice little service around it that also includes historical data that they've downloaded. So it's very similar to you guys. It's worth talking to them probably about it.
Okay.
That's what the next couple meetings are all about. I had a quick, from a different track, I had a quick question on the Energy Planner module and the calculations there, and I was wondering if that was sharing some of the same libraries from Russell and the STIR indexes and those calculations, or how that related. I know there are energy calculations built into the old Russell too. So I don't know if you had any comments on because again, I think those libraries can have multiple uses.
That's a great question, and we're going to have to go back. We generated that. We built that tool several years ago, and we're drawing a blank on where we pulled those data from. The combination of NRCS and EPA data that we use for that work, and so forgive us, but it's been a little while since we were down that road.
Oh, yeah, no worries. I know that we've started some work on the PharmOS side using the STIR. Mike, do you want to say something? Well, yeah, that's for another time. So we've got some other questions coming up. I've got another one here on the front end, maybe for Kevin, on openlayers and sort of where you're taking that. I know we've been really interested in time series data with openlayers, and just get your perspective on where we're going in terms of presentation of geo time series data with openlayers and leaflet and conversations there.
Yeah. So is a conversation just about my experience with openlayers, or?
Yeah, just sort of where we're headed with. It's something that I think is on I think a lot of our minds in terms of thinking about next steps.
Yeah, it's proved to be the most flexible spatial library for connecting to various different data sources and displaying dynamic layers. And so even with respect to different front-end libraries, so switching over to React at some point, or Angular, openlayers, it really plugs in well with those interfaces as well. So and then the fact that it's open source and still being updated quite frequently, yeah, I think that's kind of why and why we're sticking with openlayers, and kind of what we see moving forward is just upgrading to the next version of it, and then adding more layers to it.
Great.
Yeah, we're kind of in a similar boat in PharmOS right now. We're in the process of actually making a decision about Google layers. I see you said you switched over to Bing. We have Google layers in our open layers right now in PharmOS, but we're in the process of upgrading to the latest version of open layers as well, and that is just fundamentally incompatible. There is like a plugin that you can use to make it work, but we've had a little bit of trouble with it. So, or it's not perfect. So we've actually been looking at Mapbox as an alternative to that. Also.
Yeah, we went through that too. It's not compatible with the new versions of openlayers, but we found Bing to be a great replacement for the Google Maps. I prefer to use Google because it's Google. But yeah, I think that was a decision we had to make early on, and we don't regret it. It's worked out pretty well, translating over to Bing Maps for our aerial satellite imagery, and then everything else really remains the same. Just had to swap out from Bing to Google, or from Google.
And actually, what's nice about openlayers is you can actually have both. You can put Mapbox.
Yeah.
So, we're getting close to the top of the hour, but I sort of along those same lines, you had mentioned that you have import function for shapefiles, and I just wondered sort of what that process was like and what formats you currently support.
Yeah, we support a lot of formats, really every format that is available to us through PostGIS. And in the back end, we have a few libraries. I can look them up and send them to you specifically, but they're .NET libraries that allow for spatial translation. And there are some libraries we've run into, or rather some shapefile formats that we've run into that weren't supported, although it's just fairly rare, I would say. So the list is the exhaustive list available through PostGIS, and I can send that over if you'd like to look at that. And the libraries specifically are, again, .NET libraries, well-maintained, recognized spatial libraries for the translation of that. And there is a requirement in that you do have to specify, you have to have a database file to describe your shapefile. If you don't have that, then the system goes a little bit haywire.
Yeah, there's a list of supported projections. We've tested it pretty extensively with some of the most common ones like WGS 84 and NAT 83 and that sort of thing. But PostGIS is pretty flexible in that regards. But you are limited to having you have to have a description, as Kevin was saying, that is compatible with PostGIS.
Great. Well, I think thank you so much for this hour. As always, we have so much more that we can dive into, but that sort of whets our appetite for the upcoming gatherings, and we'll have many more questions, and we'll look forward to the next couple of presentations and folks joining us again real soon. Thank you all.
Thank you all.
Thanks, John.
Thanks, everyone.